Okay, so we're going to use this phone as an example to explain the support force. It is section 1.6 in your book. That would be page 22. The support force in a lot of texts is called the normal force. So realize that these two things are the same and don't let it confuse you too much. So I've got a phone on the kitchen counter and the phone is at equilibrium, right? Equilibrium, yeah. I just leave letters out all the time. We know it's at equilibrium because it's not moving. So what forces are acting on the phone? Okay, there are no pushes or pulls on the phone. I'm not pushing it, nobody's pulling it. That's not a force that's acting on the phone. Is gravity acting on the phone? Okay, so one force that's acting on the phone is gravity. Gravity is pulling that phone downward, okay? We see gravity as weight, if you remember. Weight is the force of gravity pulling down on an object. So that's one force, but the phone still isn't moving. And if only one force was acting on the phone, say if you let it go out of a plane, gravity would pull it down to Earth, but that's not happening. It's not getting pulled down to the ground. What opposes gravity? Because something has to be keeping that phone in place because of the equilibrium rule. If something's not moving, you've got to have the sum of the forces being equal to 0. And what is opposing gravity is the second force acting on that phone, and that is called the support force. Okay, so we have one force acting on the phone. The second force is the support force. Okay, that's coming from the counter. So that should be singular. So it's simply coming from the kitchen counter. It has to be equal and opposite, equal in magnitude and opposite in sign to gravity. Okay, so the support force has to equal the object's weight. So in this case, the support force equals the phone's weight. Now suppose the phone weighs a ½ pound. Not that it really matters. That means the negative force or the support force has to be plus 1/2. While gravity has to be negative 1/2. We usually see gravity because it's going down as a negative force. And the support force, since it's going upward, as a positive force. That kind of makes sense. The support force would be a plus 1/2. The force of gravity going down would be a negative 1/2. That would end up equaling 0, which is, in fact, the sum of the forces, which it's supposed to. So you can think of the phone pushing down on the atoms of the counter, and the atoms in the counter pushing back up at the phone. The last thing we have to deal with today is friction. That is 1.7 in your book. And friction is a force that resists the motion of an object. Okay? Friction is a force that resists the motion of an object. So if one object rubs against something else, be it the air or the floor or water, it is subjected to friction. So if one object is in contact with anything, it is subject to friction. Okay, sorry about that. One object that is in contact with anything at all, if one object is in contact with anything at all, it is subject to friction. So for instance, if we have, and that friction could be due to air, it could be due to the surface it's on, like the floor. It could be due to water, if you were walking through water. So let's take a look at just another one of my bad pictures. We have a box, and the box is resting on the floor, and we are pushing on the box. Okay, and the box is not moving. Why isn't the box moving? Friction is pushing back on the box. The friction between the floor and the box. I mean, there's also gravitational pull, which is pulling down on the box, but that's being canceled by the support force. Okay, if you have a ball and it's falling due to gravity, is anything acting on that ball? You might say no, but it's falling through air. So as the ball falls, it is subject to air resistance. Which is another type of friction. Okay, so we have the support force, which offsets gravity. And whenever anything is in contact with something else, you have friction, and that will resist your push or your pull or the force of gravity. And we've just about summed up all the forces.